Here we are solving Pure Math 4 Pastpaper for January 2022. In the previous video we covered question number 1 to 3. Now let's look at question number 4. This figure is given. A regular icosahedron of side length x centimeter. Icosahedron is a shape consists of 20 sides, 20 congruent equilateral triangles. Each face is a equilateral triangle. The length of the side of a equilateral triangle is x actually. So this also x. Show that the surface area is given by this. So you need to take the area of one side, multiply by 20. How do we find the area of one side? For equilateral triangle, the angle is 60 degree here. So the total surface area is 20 sides times area of one side, which is half AB sine 60. Use degree mode. Sine 60 is root 3 over 2. So this would be 10. And it's gonna be 10x squared times root 3 over 2. You will get 5 root 3 x squared. 5 root 3 x squared centimeter square. That's the surface area. Just a 2 mark question. Part B now. Given that the volume is V is equal to this, show that dV by dA is equal to this. You can write dV by dA is equal to, dV by dA is equal to, V is a function of x, so dV over dx times dx by dA, right? So dV by dx, you differentiate this, so dV over dx is equal to 5 over 12 3 plus root 5 times the derivative of x cube becomes 3x squared. Cancel this, it becomes 4. So you get 5 over 4 3 plus root 5 times x squared. So you can sub in dV by dx here. How about dx by dA? Dx by dA is a reciprocal of dA over dx, right? We know the surface area from the previous part. It's 5 root 3 x square. Differentiate it. So A is 5 root 3 x square. When you differentiate it, it becomes 10 root 3 x. So dx over dA would be the reciprocal of this, 1 over 10 root 3 x. Sub in this in the place of dx by dA. So multiply, you will get the answer already. So dV by dA is equal to dV by dx, which is 5 over 4 3 plus root 5 x squared times dx by dA 1 over 10 root 3 x. It's multiplication, so you can cancel x and x. 5 on this, it becomes 2. When you combine this, you'll get the answer already. Numerator would be 3 plus root 5 times x. And the denominator would be 8 root 3. That's all. Now let's move on to part 3 of the question. The surface area of the icosahedron is increasing at a constant rate. So whenever they say something is increasing or decreasing, it's with respect to time. So what's given here is dA over dt is given as 0.025. If the question says decreasing, you need to put a negative sign there. The rate of change, the volume, find the rate of change of the volume of icosahedron when x is equal to 2. They want you to basically find dV by dt. Since we have dA by dt, I'm going to write it in terms of A. dV by dA times dA by dt. We have calculated dV by dA in the previous part, which is 3 plus root 5 times x divided by 8 root 3 times dA by dt is given as 0.025. Now replace x by 2. So when x is equal to 2, dv by dt is equal to 3 plus root 5 times 2 divided by 8 root 3 times 0.025. Cancel, this becomes 4. They want the answer to two significant figure. Okay, so first 3 plus root 5 you can put times 0.025 here divided by 4 root 3. So they want the answer to two significant figures. So 0.19. The answer is 0.19. That's the rate of change in volume. So centimeter cube per second. That's all. Question number 5 now. We have a diagram given. Figure 2 shows a sketch of the curve with parametric equations x and y. T is from 0 to 9/4. The curve touches x-axis at t is equal to 0 and meet y-axis at t is equal to 9/4. So t is 9/4 here, t is 0 here. Okay. Read further. The region R shown shaded in figure is bounded by the curve x-axis, y-axis. Okay. Show that the area is this. To find the area, the formula is when you have Cartesian equation, it's just y dx. Integral a to b r x1 to x2. When you have parametric equations, it's y of t. Y of t is this times dx. Dx is the derivative of x times dt from t1 to t2. So if you look at the figure, the area is going to be integral. The value of x is 0 here. The x coordinate of this point is 0. The x coordinate of this point is something. We don't know the x coordinate. Let's say x1. Y dx. That's a formula, right? So if you want to take parametric equations, you need to know the value of t corresponding to x is equal to 0. The value of t is when you put x is equal to 0 and make t as a subject, it's going to be 9/4. So it's going to be 9/4 to this t value 0. Y is the y of t. T cube over square root of 9 plus 4t times. You need to differentiate x first. You have to differentiate x of t. So when you differentiate this, or dx by dt is equal to, you need to apply chain rule to differentiate it. Take the square root of x here. Derivative of square root of x is half x power half minus 1 times. Differentiate 9 minus 4t, you will get negative 4. So when you simplify, you will get minus 2, because now negative 4 divided by 2 divided by 9 minus 4t power positive half, right? So you can write it as minus 2 times square root of 9 minus 4t dt. That's the integral. So what they want us to prove in part A? They want us to prove this can be written in this form with a number k outside. So that's what we are going to do now. Combine them. This one a plus b times a minus b, you can write it as a square minus b square within square root, and then on top keep t cube as it is. If you flip these two limits, it becomes 0 to 9/4, but you need to put a minus in front. But you already have a minus, it becomes positive 2 dt. Why I flip the limits? Because they want the limits as 0 to 9/4. So the value of k is equal to 2 in this case. The value of k is 2. That's all. So it's a 4-mark question. Let's look at part B of the question. Now we need to integrate the function we got from part A, and we need to find the value of it using the u substitution. So basically you need to convert everything in terms of u. So that's what I'm gonna do first, one by one. So you put 2 integral, first the limit, you draw a little table, the limits of t are 0 and 9/4, u is 81 minus 16 t square. When you replace t by 0, it's 0, sorry, it's not 0. When you replace t by 0, it's going to be 81. When you replace t by 9/4 here, it becomes 9/4 whole square times 16 is going to be 81. 81 minus 81, 0. So the lower limit corresponding to 0 is 81. The upper limit corresponding to 9/4 is 0. So usually for changing the limit, you can draw a little table and show that. That's how you change the limit. Now I'm gonna change first this one. This is basically, the denominator is basically square root of u. How about the numerator t cube? We have to take u is equal to 81 minus 16 t square. Make t as a subject, 81 minus u. So t square is equal to 81 minus u by 16. T is going to be square root of it. But we need t cube, so cube both sides. This becomes 81 minus u by 16 power 3/2. So 81 minus u by 16 power 3/2. That's it. Now we are going to convert dt in terms of u. So take u, differentiate it. Du by dt is minus 32t. So du by minus 32t is equal to dt. So in the place of dt, I'm going to put du divided by minus 32t. T is this, right? 81 minus u by 16 power half. So we have converted everything in terms of u already. We need to simplify it carefully and then integrate it. So first what I'm gonna do, let me rub this thing off. First I can cancel this, I will get negative 16. So minus 1 over negative 16 integral 81 to 0. But when I swap the limits, right, you have to put one more negative sign in front, so it becomes positive 0 to 81. 0 to 81. And then 1 by square root of u. You have this and this. The base are same, so you can subtract the power. 3/2 minus 1/2 is just 2/2 is power 1. 81 minus u by 16 du. You can take the 16 also outside. 1 over 16 times 16, 256 integral 81 by root u minus u by square root of u du, which is 1 over 256 integral 0 to 81. 81 u power minus half u power positive half du. So when we integrate it, we will get 1 over 256, 81 u power minus half plus 1, which is positive half by positive half, minus u power half plus 1, which is 3/2 by 3/2. The limit is 0 to 81. When you sub in the lower limit 0, everything becomes 0. So first I'm going to sub in the upper limit. 1 over 256. 81 by half is 162. 81 power half minus 2 over 3. 81 power 3/2. That's upper limit minus lower limit is 0. I'm going to use my calculator to simplify this. See how I'm writing is 1 over 256 times 162 times 81 power half is 9 minus 2 over 3 times 81 power 1.5 and then close the bracket. 243 over 64. 243 over 64 is the answer. That's all. Question number 6. Prove by contradiction. 3 consecutive terms in a sequence of real numbers are given by k, 1 plus 2k, 3 plus 3k, where k is a constant. Use proof by contradiction to show that this sequence is not a geometric sequence. For all proof by contradiction question, you need to write the assumption first. Assumption is usually the opposite of the original statement that we are trying to prove. So k, 1 plus 2k and 3 plus 3k form a geometric sequence of real numbers. You need to put real numbers. That's very important, because we are going to prove now k is not a real number. That contradicts the assumption. Okay. Since these 3 terms form a geometric sequence, you can find the common ratio. Second term divided by the first term, that would be equal to third term divided by the second term. And then cross multiply. You will get 1 plus 2k times 1 plus 2k is equal to k times 3 plus 3k. So I'm going to expand the bracket and put everything one side. We'll get 1 plus 4k plus 4k square on the left hand side, and then 3k plus 3 square minus 3k minus 3k square is equal to 0. Simplify the like terms. We'll get k square plus k plus 1 is 0, which is a quadratic equation. You need to solve this quadratic equation. K is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. I'm going to straight away use my calculator to solve this. 1, 1, 1, all the coefficients are 1. So is equal to minus 1 over 2 plus or minus root 3 by 2i. Not a real solution. It's a complex number. You don't need to know about complex number. When you see I here, it's called a complex number. You don't need to go deep into it actually. It's not a real solution. Therefore, k is not a real number. But actually this contradicts the assumption, because in the assumption we have mentioned that these 3 terms are real numbers, right? So you need to write the 3 steps at the end, the conclusive steps. What you need to do? What you need to write? You need to write this contradicts the assumption that these 3 terms form a geometric sequence of real numbers. Therefore the assumption is wrong. And then finally you need to write 3 consecutive terms in the real number given by this are not a part of geometric sequence, or they don't form a geometric sequence. You need to write the conclusive statement, otherwise you will lose more. That's all.